we have already know that d by dx of f of x is equals to f of x. So that is, if we differentiate the function f of x, then we are getting f of x. The natural question generally arises if we are given the derivative. What is this f of x? This is derivative of f of x. So the question is, if we are given the derivative, so is it possible to evaluate the function? So if so, is it unique? And this process of finding the antiderivative is called the reversal process of a differentiation is called the integration. So that is, integral f of x dx is equals to f of x plus c. So integral f of x dx is equals to f of x plus c. So the original function we are getting here. So we already know that the geometrical interpretation of differentiation is the finding the slope of a tangent to the curve. For example, this is the curve. So we are finding the slope of this tangent. This is the geometrical interpretation of the differentiation. So likewise, this is the indefinite integral. So let integral f of x dx equals to f of x plus c. So what is integral a to b f of x dx? This we have learned that f of x plus c from a to b. So fb plus c upper limit minus of fa plus c. So c gets cancelled. We are left with fb minus fa. This value represents the definite integral. This value represents the definite integral. So let us discuss what is the geometrical interpretation of integral a to b f of x dx. It is nothing but the area of the, so if y is equals to f of x is a continuous curve and this is x equals to a, x equals to k is the line which is parallel to y axis, that is a vertical line. So this is x equals to b and this is x axis. Therefore this is nothing but integral a to b f of x dx. That means integral a to b f of x dx denotes the area of the region bounded by the curve y is equals to f of x, x equals to a, x equals to b and x axis. Here the natural question generally arises that, see, this is not the regular shape. So far we already familiar with finding the area of a circle, triangle, trapezium, rectangle, square, etc. But actually this is a complex curve. Sometimes actually some curves will be like this. So we need to evaluate the area of the region bounded by this typical curve y is equals to f of x, x equals to a, x equals to b and x axis. Therefore it is totally bounded. Now we need to find out the area of the region bounded by this y is equals to f of x curve, x equals to a, x equals to b and x axis, this area. So to find out to evaluate the area of the region bounded by this kind of typical curves, what we are doing is, we are already familiar with the area of the rectangle. Area of the rectangle is length into breadth or width into height, whatever you can take into consideration. So that means this area, for example, so if we take this like integral, this curve is there, this is x equals to a, this is x equals to b, and this is y is equals to f of x curve, and this is x axis. So this area I want, for which what I am doing is I will make this to be the rectangle, and this area I will find. But in the process of finding this area, actually this area is missing out, for which this is not the correct area. So some area of the region is being missed out, for which what I am doing is, if I make this into two halves, okay, then this area also if I find, then this time with compared to the earlier one, earlier actually this much of area has been missed out. With compared to the earlier, this time this area only left out. So with compared to the earlier one, this area is coming more approximate value with compared to earlier. And if I make this into further strips like this, further rectangles, what I mean to say is, then this area if you join, so this time, so here only this area is miss out. That means as we keep on increasing the rectangles, as we keep on, first this rectangle only I have taken, so actually this much of huge area has been missed out. Secondly I made it into two rectangles. With compared to the earlier, a more improvement has come out, and this time actually 4 rectangles I made out. Therefore only this part of this has been missed out. Therefore, so we got an idea that if we keep on increasing the rectangles, then actually the more improvement in terms of rectangles areas are coming out. So with this actually we develop a concept. With the help of that actually we will be trying to find out the area of the region bounded by the curve y is equals to f of x, y is equals to f of x, x equals to a, x equals to b, and x axis we will evaluate. So this is y is equals to f of x curve, this is x equals to a, x equals to b, and x axis. So for this, let us try to split the rectangles, n rectangles. So this is a, if I take another rectangle, this is of having width h. How much width? H. So then this will be a plus h. So this is a plus h. If I take the further rectangle, this is a plus h plus h. So this is a plus 2h. So this is how much? A plus 2h. And the further one is, if I take this, each having the width h. This width is how much? H, etc. So this is how much? A plus 3h. Likewise, let us split the n rectangles. So that means this is one rectangle. So this is between a and a plus h. Another rectangle a plus h to a plus 2h. This is a plus 2h to a plus 3h. So since n rectangles are there, the last rectangle will be how much? A plus nh. What is this? X equals to b. So, and if I take the previous rectangle, this width is also h, and this is a plus n minus 1 into h. So like this I split. Now So that means area of the region bounded by the curve y is equals to f of x equals to a, x equals to b and x axis. Since this is not a regular curve, so for which actually we have splitted n rectangles, each having the width h. So that means this is one rectangle and this is another rectangle, this is another rectangle. So likewise, so this is, for example, if I take like this, then this is another rectangle. So actually it is seemed to be a rectangle but not a rectangular, because actually this shape, some bulge shape has been come out. So now the sum of all areas is equals to Sn is equals to, so if I take the first rectangle, so this, okay, this having the width, so this is of this form, this is of this form, and this is having the width h, and this is a, this is a plus h. So we know that the area of the rectangle is width into height. So if it is a, can you tell me what is this height? Since this is y is equals to f of x curve, since this is y is equals to f of x curve, simply substitute this a value in this, then actually this is f of a we will get. So what is this a? F of a, this is the height. So if I take the first rectangle, h into f of a plus, if I take another one, so actually this is what I have. So this is also having h width, this is also h width, and this point is a plus h. So this is equals to f of a plus h. So h into height into width, h into f of a plus h. So the next term will be h into f of a plus 2h, etc. plus. Let us come to the last rectangle. For this last rectangle, a plus n minus 1 into h, h into, this is width into height is a plus n minus 1 into h. You may ask a question, why can't a plus nh? Because if I take the first rectangle this, so the left side, this is a into f of a into h. If I take this rectangle, this is h into f of a plus h. So last rectangle is h into f of a plus n minus 1 h. If I take h into f of a plus n h, it will go beyond the interval. Therefore, the last would be h into f of a plus n minus 1 into h. H into f of a plus n minus 1 into h. So here in each and every rectangle h is common. So f of a plus f of a plus h plus f of a plus 2h, etc. plus f of a plus n minus 1 into h. F of a plus n minus 1. So since h is taken common, so but if I take this is not the accurate area, because actually in finding this, actually some part of this is missing. So this and this, so likewise actually so much part of this is getting missed, for which what we are doing is we are trying to take the maximum infinite number of rectangles. So earlier n rectangles we have taken. Here we will be taking the infinite number of rectangles. If I take infinite number of rectangles, so very first thing, for example, so this is what I get. So this is h and this is f of a. So but if I reduce this h to this, then with compared to earlier, this much is missed. Earlier, if h is this, then actually this much of this area we are getting, and this much of it is missed. If I try to reduce this h like this, then only with compared to earlier, this is missing out. That means if I take a maximum infinite number of rectangles, that is as n tends to infinity, that is number of rectangles are infinity, h is tending to 0 because h is equals to b minus a by n. Because here see this is a plus nh is equals to how much? B, or nh is equals to nh is equals to b minus a, or h is equals to b minus a by n. H is equals to b minus a by n. Okay, that means the total area is b minus a. This is equals to, since it has n rectangles, each is having the width h, so nh. So it is connected by the relation b minus a is equals to nh. So h is equals to b minus a by n. So as n is tending to infinity, h is equals to b minus a by n. So h is tending to, h is almost become, this width becomes 0, because if I take n number of rectangle, earlier n number of rectangles of each having width h have taken, this time n we are maximizing, we are increasing the number of rectangles. If we are increasing the number of rectangles, then actually this height will be reduced to 0. So this is equals to, I am coming to the point now. So what is Sn? Integral a to b f of x dx. The area of the region bounded by the curve y is equals to f of x between the limits a and b is equals to, so limit h tends to 0, or first limit n tends to infinity, as the number of rectangles are infinity, then h into f of a plus f of a plus h plus f of a plus 2h etc. plus f of a plus n minus 1 into h. So since n is tending to infinity, h is tending to 0. So what is h? b minus a by n. So h into f of a plus h plus f of a plus 2h etc. plus f of a plus n minus 1 into h. So this is the formula for finding the definite integral as a limit of a sum. Let us discuss the problems from the integral as a limit of a sum. Exercise 7a. Evaluate the integral following integrals as a limit of a sum. The first question is, first question, integral 0 to 5 x plus 1 dx. So the formula is integral a to b f of x dx is equals to limit h tends to 0 h into f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1h. So here f of x is equals to x plus 1, a is equals to 0 lower limit, b is equals to 5 upper limit, h is equals to b minus a by n. So that is equals to 5 minus 0 by n. So that is equals to nh. nh is equals to 5. Now integral, so before that, what is f of a? Let us find out. F of a is equals to so f of 0, substitute in that. So 0 plus 1 is equals to 1. Next, f of a plus h, that is equals to f of 0 plus h. h is equals to 5 by n, that is equals to 5 by n plus 1. f of a plus 2h is equals to f of a is equals to 0, 2h. So 2 into h value is 5 by n. 2 5s are 10 by n. If f of x is equals to x plus 1, f of 10 by n is 10 by n plus 1 and goes on till f of a plus n minus 1 into h, that is equals to, so we have so many. So and f of this is n minus 1 into h, h is equals to 5 by n, h is equals to 5 by n into n minus 1, that is equals to 5 by n into n minus 1 plus 1. So let us substitute all of them in the given equation. So integral a to b f of x dx is integral 0 to 5 x plus 1 dx is equals to limit h tends to 0. The value of h is so h, let us write in the first step. F of a is 1, f of a plus h is 5 by n plus 1 plus 10 by n plus 1 etc. plus 5 by n into n minus 1 plus 1. That's it. So limit h tends to 0, h here 1 1 1 1. So these are n number of ones, n into 1 plus here 5 by n, here 10 by n, 5 into 2 by n etc. So this is n minus 1, this is okay. Next, so 5 by n if I take common, then in this 1 2 3 etc. 5 by n if I take common, n minus 1. This is equals to limit h tends to 0, h into, so n number of ones, so n plus 5 by n, this is sigma n minus 1, this is sum of n minus 1 terms. This is equals to limit h tends to 0, h into n plus 5 by n. Remember the formula sum of n terms. Sum of n terms is equals to n into n plus 1 by 2. So if it is sigma n minus 1, then in the place of n, substitute n minus 1. So that is equals to n minus 1 into n minus 1 plus 1, which is n by 2. So the same thing I am applying here. Sigma n minus 1 is n into n minus 1 by 2. So this n gets cancelled. Limit h tends to 0. So this is n into h plus 5 by 2 into this is nh. H I am multiplying with both the terms inside minus h. That is equals to limit h tends to 0 nh plus. So now initially h is equals to how much I have taken? B minus a by n. So that is 5 minus 0 by n. Therefore h is equals to 5 by n. Other words, nh is equals to cross multiplication is equals to 5. This 5 I am replacing here. So nh is 5 plus 5 by 2 into nh value is 5 minus limit h tends to 0. So this h will be 0 here. So 5 plus 5 5s are 25 by 2. 2 5s are 10 plus 25, 35 by 2. So integral 0 to 5 is x plus 1 dx is equals to 35 by 2 we get. But if we want to know whether the whether the solution is correct or not, we can do the direct method. What is that? The fundamental theorem of integral calculus. What is the fundamental theorem of integral calculus? Integral a to b f of x dx is equals to, so f of x from a to b, that is equals to fb minus fa. So here what is this f? So integral 0 to 5 x plus 1 dx is equals to integral x dx is x square by 2 plus integral 1 dx is x from 0 to 5. This is equals to 1 by 2. In the place of x, substitute upper limit 5 square minus in the place of x lower limit 0 square plus in the place of x 5 minus 0. 5 square 25 by 2 plus 5. The same answer we are getting 35 by 2. So we can compare like this. Do the next question, integral 0 to 4 x square dx. Here f of x is equals to solution. Here f of x is equals to x square. Lower limit a equals to 0. Upper limit b is equals to 4. And h is equals to b minus a by n. B is equals to 4 minus 0 by n. That implies nh is equals to 4. So we have integral a to b f of x dx is equals to limit h tends to 0 h into f of a plus f of a plus h plus f of a plus 2h etc. plus f of a plus n minus 1 into h. F of a is equals to f of f of 0 is equals to 0 square, which is 0. F of a plus h is equals to f of 0 plus h is h. So h square. F of a plus 2h. F of 2h. F of x is x square. F of 2h is 2h whole square. So 2h whole square, which is 4h square, or this is 1 square h square we can write. This is 4h square, which is 2 square h square. So etc. f of a plus n minus 1 into h. This is equals to f of 0 plus n minus 1 into h. This is equals to n minus 1 whole square into h square. So this is equals to, therefore, integral 0 to 4 x square dx is equals to limit h tends to 0 h into f of a plus f of a plus h plus, so what is this f of a? 0 plus a plus h is 1 square h square plus this is 2 square h square etc. plus n minus 1 whole square into h square. So this is equals to limit h tends to 0 h into, so here h square if I take common, this is 1 square plus 2 square plus etc. plus n minus 1 whole square. Limit h tends to 0 h into h square into, this is sigma sum of squares of n terms n minus 1 whole square. So we know what is sigma n square, sum of squares of n terms, n into n plus 1 into 2n plus 1 by 6. But here sigma n square means sigma n minus 1 whole square, that is equals to, wherever you have n simply substitute n minus 1. So n minus 1, n minus 1 plus 1 n, 2 into n minus 1, 2n minus 2 plus 1, so 2n minus 1 by 6. Simply that value we will substitute here. Limit h tends to 0 h into, this is n minus 1 into, this h square is already there, into n minus 1 into n into 2n minus 1 by 6. This is equals to limit h tends to 0. This is h into h square h cube. So we will do one thing. One h we will give it to hit, another h and another h. So h will be shared among these three. Okay. So this is equals to 1 by 6 if I am taking aside, then h into n minus 1 nh minus h into n into h into 2nh minus 1 into h is h. So that is equals to, now 1 by 6 into the value of nh, h is equals to b minus a by n, 4 minus 0 by n, so nh is equals to 4. Let us substitute 4 minus limit h tends to 0, if tending h is equals to 0, if we substitute in this 0, so this is nh value is 4 into, this is 2nh, 2 4s are 8 minus h value is 0, that is equals to, so 4 into 4 into 8 by 6, so 2 2s, 2 3s, 64 by 3. We will see integral 0 to 4 x plus e power 2x dx. As usual, here f of x given function is x plus e power 2x. Lower limit a equals to 0, upper limit b equals to 4, and h is equals to b minus a by n, that is equals to 4 minus 0, so 4 by n. Further nh is equals to 4. Now integral a to b f of x dx. What is the integral limit? What is the definite integral as a limit of a sum? Integral a to b f of x dx equals to limit h tends to 0, h into f of a plus f of a plus h plus f of a plus 2h etc. plus f of a plus n minus 1 into h. Now let us evaluate f of a. What is f of a? F of a value is 0. So f of 0 is equals to 0 plus e power 2 into 0. So e power 2 into 0 is 0. E power 0 value is 1. F of a plus h. F of 0 plus h value. So this is equals to f of h is h plus e power 2h. F of a plus 2h, a value is 0, so 2h. This is equals to 2h plus e power 2 into 2h etc. F of a plus n minus 1 into h. This is equals to f of n minus 1 into h. This is equals to n minus 1 into h plus e power 2 into n minus 1 into h. This is equals to integral 0 to 4 x plus e power 2x dx is equals to limit h tends to 0, h into f of a value is 1 plus this value is f of h value is h plus e power 2h plus 2h plus e power 2 into 2h is 4h plus etc. plus n minus 1 into h plus e power 2 into n minus 1 into h. This is equals to limit h tends to 0, h into 1 plus this is h. If I take common, h plus 2h etc. So what I am doing is, here h is there, 2h, n minus 1h. So h if I take common, 1 plus 2 plus etc. plus n minus 1. So plus e power 2h if I take, so here 1 plus e power 2h plus e power 4h plus etc. plus e power 2 into n minus 1 into h. This is equals to limit h tends to 0, h into this is AP series. The common difference is 2 minus 1 1. So this is sigma n minus 1, sum of n minus 1 terms, plus this is 1 plus e power 2h e power 4h. This is a geometric progression because the common ratio is e power 2h by 1 is e power 2h. So we have a series AR square etc. AR power n. This is sum of squares of sum of n terms of GP is Sn equals to A into R power n minus 1 by R minus 1. This is the formula. So here A is first term. A is the first term plus R is the common ratio e power 2h minus 1 by R minus 1 whole power n. A into, so 1 into R power, R value is e power 2h whole power n, because this starts from A to R power n. That means sum of n terms. Here starting from 1 to this, here also n terms only. N minus 1 by R minus 1 e power 2h minus 1 equals to limit h tends to 0, h into h sigma n is equals to n into n plus 1 by 2, sum of n natural numbers. So now sigma n minus 1 is n minus 1 plus 1 n. So this is n minus 1 into n by 2 plus e power 2nh minus 1. This h when bringing inside into h by e power 2h minus 1. This is equals to limit h tends to 0, h I am bringing it inside. So h into n, nh, h into n minus 1 is nh minus h by 2 plus e power 2nh minus 1 by e power 2h minus 1. This into h is 1 by h. Can I write? This is equals to, so what is nh? H is equals to 4 minus 0 by n. So 4 by n. From this nh is equals to 4. This shortly we will using it. So limit h tends to 0, nh into nh minus h by 2 plus limit h tends to 0, this e power 2nh, this is 2 power nh minus 1 into by, this is limit h tends to 0, e power 2h minus 1 by h. So here we have a formula that limit x tends to 0, e power x minus 1 by x is, limit x tends to 0, e power x minus 1 by x is equals to 1. That means here, everywhere same x is to be maintained. So here what I am doing is 2h I will multiply, because if it is 2h, this is x, e power x minus 1 by x. So 2h tends to 0 also, into 2 I will do. I will multiply and divide with 2, and since it is, the formula is limit x tends to 0, e power x minus 1 by x equals to 1. So this is limit, if you take it as x, limit x tends to 0, e power x minus 1 by x. So this is equals to, nh value is 4 into 4, as h tends to 0 if I substitute here, so 4 minus 0 by 2 plus e power 2nh value, nh value is 4, 2nh is 2 4s are 8 minus 1 by, the value of this is 1, this value is 1 according to this property, into 2. So 2 times 2 4s are 8, e power 8 minus 1 by 2, 2 8s are 16 plus e power 8 minus 1 by 2. Answer is 16 minus 1, so 15 plus e power 8 by 2 is integral 0 to 1 x minus x square dx. F of x is x minus x square. A value is lower limit 0, upper limit b equals to 1, h is equals to b minus a by n, 1 minus 0 by n, so that is equals to nh value is 1. So we have a formula integral a to b f of x dx is equals to limit h tends to 0, h into f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1 into h. Now, what is the value of f of a? 0 minus 0 square, 0, f of a plus h, so 0 plus h, h value, so 0 plus h, f of a plus h is equals to f of h, that is equals to h minus h square, f of a plus 2h, f of 2h, this is equals to 2h minus 2h whole square, etc. f of a plus n minus 1 into h, this is equals to f of n minus 1 into h, this is equals to n minus 1 into h minus n minus 1 into h whole square. Now let us substitute in this. Integral 0 to 1 x minus x square dx is equals to limit h tends to 0, h into the value of f of a is 0 plus h minus h square plus 2h minus 2h whole square, etc. plus n minus 1 into h minus of n minus 1 into h whole square, that is equals to limit h tends to 0, h into here h, 2h, etc. n minus 1h. If I take h in common, 1 plus 2 plus etc. n minus 1. Okay, so that is equals plus here minus h square 2h whole square. So h square if I take common, then here 1 square, here h square, 2 square h square, h square if I take common plus 2 square, the next term would be 3 square, etc. Since minus is taken common, it would be plus n minus 1 whole square. This is equals to limit h tends to 0, h into this is sum of n minus 1 terms minus h square into this is sum of squares of n minus 1 terms. So we already know limit h tends to 0, we already know sigma n is equals to n into n plus 1 by 2. Likewise sigma n square, sum of squares of n terms, n into n plus 1 into 2n plus 1 by 6. This we know already. H into sigma n is n into n plus 1 by 2. Sigma n minus 1 by 2 is n minus 1 into n by 2. N minus 1 into n by 2 h minus h square into sigma n square is this. Sigma n minus 1 whole square is n minus 1 into n into here 2n minus 1 by 6. That is equals to limit h tends to 0. So h into, so here h into n, nh minus nh, h into n is nh into this h if I multiply inside nh minus h by 2 minus h into h square h cube. Let us do one thing. One h I will give it to this, one another h and another h I will give it to this. So as a result of that, nh minus h, nh, 2nh minus h by 6. Now we have to substitute nh is equals to 1 in this to obtain the answer. So this is nh value is already we know nh is equals to 1. 1 minus 0 by 2 minus nh value is 1 minus 0. This is 1 into 2 ones are 2 minus 0 by 6. 1 by 2 minus, this is 2 by 6 is 1 by 3. So 3 minus 2 by 3 2s are 6, which is 1 by 6.